Alright, today we're going to be exploring X and Y-intercepts, but before we dig into that, I want to draw on some previous knowledge about what we've done in class. I want to discuss domain and range and interpreting graphs. And so if we look at this graph, it gives us the amount of money on a loan. So the amount of money is our dependent variable, and the month since taking out the loan is our independent variable. And so I want you to think about what that means. So think about things that you would take out a loan for. Some of us might have experience with family members taking out a loan, maybe for a house or a car or for school. And when you take out a loan, the bank or the lender gives you money, and then you have to pay that money back. So what I want you to do right now is pause the video and take a few minutes to try and answer these problems on your own. You can check your answers in a group, talk with your partners, but work on your own. And then when everyone is done, we'll watch the video and I'll go through my thoughts on this. All right, now that you guys have done this on your own, let me talk through my thoughts. So this says, what is the domain? And in my head, I'm thinking, well, domain, those are the input values or the x value. So when I go to my graph, if this is my x-axis and this is my y-axis, the domain are all of the possible x values. When I look at the graph, I have a continuous function. So looking at this, I'm saying, well, it's the x values. If I bring this down onto the number line, I'm looking at this and I'm thinking, well, it starts at 0, and it goes all the way here, keeps going, and then it ends at 8. So if I'm thinking about domain, it would be all of these values. If you think back to what we talked about with inequalities, to show that we would need a compound inequality that whose lowest value is 0 and highest value is 8. And we're going to include those because it looks like it actually hits those values. So I know that that means we have 0 is less than or equal to x, which is less than or equal to 8. The range are the possible output values, or the y values. And so when I do that, I'm going to be looking up and down on the y-axis. So I go where it starts. The graph starts down here, and it goes all the way up, the graph, and then stops there. So the y values are everything along here. And again, if you picture this like a number line like that, you're looking at just a segment, so we would need a compound inequality in order to name this range. And so to do that, I go from the lowest value to the highest. The lowest value would be 0 then. The highest value, well, it's right in between 3,000 and 4,000, so I know that that is 3,500, and there is my range. So again, I've highlighted the domain and range in pink. It says, where does the graph intersect the horizontal axis? I know the horizontal goes this direction, and so here's the horizontal axis. I'm going to highlight that in blue. All right, so that's what the point is. I'm going to write it as a coordinate. That would be 8, 0. And what that means is when x is 8, y is 0. Well, let's think about what that means in the context of the problem, because the next point asks, what does this point represent in the situation? Well, x, the independent variable, is the number of months since taking out the loan. So after 8 months, the y, the dependent variable, is 0. So the amount I owe on the loan is $0. So if I don't owe any money on the loan, I've paid back the loan. So what that means is I have paid back my loan after 8 months. The next question says, where does the graph intersect the vertical axis? And I know vertical means up and down, so I'm going to circle that in green and plot that point. This is where the graph intersects the vertical axis. The ordered pair there is 0 for the x, y is 3,500. So what that means is when x is 0, y is 3,500. Or when the number of months since taking out the loan is 0, then the y, the amount on the loan, is 3,500. So what that means is, well, if months since taking out the loan is 0, that means no months have passed. It's at the beginning. It's the starting point. So I'm going to make a little note here. When we're talking about that, it is the starting point when x is 0. So the starting point then means that's how much money I started out owing. That's how much I took out. So I owe $3,500 at the start of my loan. And there you go. We're going to use that now to start talking about X and Y intercepts. So your X-intercept, the definition, if we scooch down here, is going to be the point, or in some cases, the points plural, where the graph intersects, in other words, crosses the x-axis. And the y-intercept is going to be the point, or in some cases points, where the graph intersects, meaning crosses, the y-axis. The definition of these two is very similar. The only difference is crossing the x-axis versus the y-axis. And I'm going to use green and blue to highlight these so I keep track of x-intercepts versus y-intercepts. I'll be consistent throughout these notes. Okay? So what I'd like us to do then is to look at example 2. Let's read the directions. The directions say, given the graph, determine whether the graph is a function. So that's the first thing. That's what we're going to write here. Is it a function or not? We studied that earlier in this unit. Find the domain and range, here and here, and then determine the x and y intercepts. So that's what we're going to list here. So I want you to pause the video and attempt these on your own. Once you've attempted it on your own and talk through it as a group, then go ahead and play the video and watch listen for my explanation. All right, so now looking at this, when I see these arrows, I know that this really goes on forever and ever and ever. This goes on forever and ever and ever. So if it's helpful to draw that, go ahead and draw that. The first question is it a function? I'm looking at this graph, and it's a continuous graph. So what I want to do is use a vertical line test to determine whether or not this is a function. So if I take my pencil and draw these vertical lines, so far it looks like as I go through that this vertical line hits only once. If it hit any point, if the vertical line hit 2 points, then we would not have a function. But because the vertical line only hits 1 point at any given time, then it is a function. So yes, my explanation is the graph passes the vertical line test. For the domain, I remember that domain is the input values, or the x values. So there's my x-axis, here's my y-axis. So x goes left and right. So going to the left, this graph is never stopping. So it would be everything on this number line to the left. And if we go to the right, the graph is never stopping going to the right. So it's this entire number line. Well, if it's everything on the number line, we don't need an inequality to represent it, because inequalities help us if they have a stopping point. So what we can say is everything on a number line means all real numbers. We can write out all real numbers, or we can use the capital letter R that has 2 bars there. The range are the possible input values, or y, so that goes up and down. So as I go down, going down as all of these, I have the graph here. This looks like the lowest point. So as I go over to the graph, this is as low as the y values go. There's nothing below it. So I have a graph going up from here. So all of these numbers are going to get hit. All of them are going to get hit. And then I see these arrows at the end, so we go up like that. So if you picture this like a number line, we start out here with negative 1, 2, 3, 4, 5, 6, 7, and then it's everything to the right of negative 7 or above negative 7. So I have to think through back to inequalities. If I have negative 7 or anything above that, I have to think through what inequality I could use to write that. So what I know is I don't need a compound inequality. I'll just use a single inequality. It'll be y is greater than or equal to negative 7, because it's everything above negative 7 or and including negative 7. So now the x-intercepts. I'm going to highlight these in blue. I look at the x-axis. I'm going to make in blue these dots where it crosses the x-axis. So those are my x-intercepts. My y-intercepts are where the graph crosses the y-axis. So I go here, there's only one y-intercept. So now let's list these as ordered pairs. The x-intercept, that's negative 1, 2, 3, 4, 7. So we have negative 7, 0. Looks like we have negative 3, 0. positive 2 comma 0, and then all the way over here 4 comma 0. For the y-intercept we have 1, 2, 3, 4, 5, just 0 comma 5. And so when we look at this, I want to start noticing a pattern for all x-intercepts and y-intercepts. When we look at the x-intercepts, let's think, what do they all have in common? Well, as I look at this, I notice that here, all of these y-coordinates are 0. So let's make a note of that. The y-coordinate, meaning the second number when we're writing the ordered pair, is always 0. We only have one y-intercept, but you'll notice that the x-coordinate is 0 here, and when we go up to the problem that we did up here, that y-intercept had an x-coordinate of 0 as well, and that is actually true for any point on the y-axis. So here we have the x-coordinate is always 0. And so what I'd like to do is take a look back up where we had the definitions, and let's add something to that. So scooching back up here, underneath here I want to write that when you have an x-intercept, you're going to have something, comma, 0. And we have the y-intercept, it's going to be 0, comma, something. So that's going to be helpful for us as we continue on with the rest of the notes today. Let's go ahead and flip to the back. And as we look in the back, there's another problem where we're given a graph. It's asking us whether it's a function or not to determine the domain and range and list the x and y intercepts. Go ahead and pause the video and try this on your own, and then we'll discuss our answers. Alright, now that you've tried it on your own, let's talk through this. Is this graph a function? Well, as I take my vertical line, knowing that this is a continuous function, or continuous graph rather, I look at the vertical line, and this time, when I draw a vertical line, the line intersects the graph in 2 different points, which means that when x is -4, we have 2 different outputs. And that can't happen for a function. So is it a function? No. We can say the graph doesn't pass the vertical line test. If it's not a function, we don't even worry about the domain and range, so we can skip that. So moving on to x and y intercepts. I said all of the x-intercepts I was going to highlight in blue. Let me make sure I did that. Yep. X-intercepts are in blue. So I go my x-axis. Here's the graph crossing. Crosses again. So here are my x-intercepts. My y-intercepts go to the y-axis. The graph crosses here and here. So we actually have 2 of each now. Let's go ahead and list the coordinates. For the x-intercepts, I go to the left 8, so that would be a -8, comma 0, and to the right 8, positive 8, comma 0. The y-intercept, I go up 4, so that would be 0, comma 4, 0 because I'm not going left and right any, and then I'm not going left or right any again, so it would be 0, comma, -4. Make sure that the 0 is in the correct ordered pair, or in the correct coordinate. All right, moving on to example 4. Now we're moving on to a table. So we've looked at the graph. We know that the graph has x and y intercepts where the graph crosses the x and y axis. But now we're looking at a table, so we don't even see a graph. So in your groups, try and figure out, for A, how can you figure out what the x and y intercepts are if you don't have a graph? Go ahead and try this on your own. After you've tried it on your own, listen to the video for an explanation. All right, so now when I'm looking at this, I remember the pattern that we said. The x-intercept is where the y-coordinate is 0. The y-intercept is where the x-coordinate is 0. So when I look at this table here, I see a 0 for x here, which means that my y-intercept is right here. And I see a 0 for y down here, which means the x-intercept is right there. So the x-intercept can be 1, comma 0. And the y-intercept will be 0, comma 3. Now that we've talked through this one, try part B on your own and pause the video. Now that you've tried part B on your own, listen through how I think through this. When I look at this, the only 0 I see is when y is 0. I remember when y is 0, that's my x-intercept. I'm going to circle that in blue. Okay, so I know my x-intercept is 2, comma 0. To find the y-intercept, I know I need to look where x is 0, and I don't see x being 0 anywhere. But if you notice, there is a pattern here. So in red, I'm going to note our pattern. For the x values, we are increasing by 1 each time. And for the y values, we are increasing by 5 each time. So there is a pattern. And when there's a pattern, we can extend this table to find other values. So in other words, if I keep going, I add 1 again, I have 6, 20, and so on. But I don't want to go further and further, or like higher numbers for x. I want to get closer to 0. So if I go backwards, instead of adding 1, I can subtract 1, and I can get 0. Instead of adding 5, I'll subtract 5 and get negative 10. And now I have found my y-intercept. So that one was a little tricky, but it helps us if we remember to look for patterns. So 0, negative 10 is our y-intercept. Now I'd like to do an introduction with function notation. Function notation has to do with functions. Function notation is just a fancy way of writing equations with functions. So for example, last year you probably looked at equations that looked like y equals 3x plus 20. Well, instead of saying y equals 3x plus 20, we're going to write the y using function notation. So there's going to be an f, a parentheses, an x, and then we're going to close that parentheses. Now, this is not f times x. This is read as f of x. What it means is that x is the input of the function. So if this equation represents a function, then we can use function notation. We can say f of x instead of y. Think of this as like the more formal name, and this is the less formal. In other words, my friends will call me Jess or Jessie, but you guys call me Mrs. Vanston. So think of this as Mrs. Vanston, this is Jess or Jessie. They still refer to me. They refer to the same thing. This is y, this is f of x. They're written in a different way. So what this means is you take an input, the input is x. You are inputting it into a function. The equation that we have is 3x plus 20. That is our function. We can call this function f. And after you do these operations and have that relationship, then it pops out the output, or the f of x, or in other words, the y, same thing. So you do some operations to x and you get y or f of x, the output. So in this case, let's say we wanted to have the input as 3. What it means is 3 goes in. You have 3 times 3 plus 20. That's the operation you're going to do. Remember, in order of operations, we have to do multiplication first. So 3 times 3 is 9, plus 20 is 29. So it's going to pop out, excuse me, 29. 29 will be the output. So how we write that is the function f, so remember f, whose input is 3, equals or has an output of 29. So that is a main idea. So let's take a look at this. Our x is the input. It's denoted here. We put the input in. So 3 replace the x. It's still denoted here, and it pops out what the y coordinate is. So I will do the y value, or the output, in purple. So I have y, which is the same thing as this, pops out here and here. So 29 is the output. It's like the y. So what that means is if I write this as an ordered pair, it's x comma y. This means the exact same thing using function notation. So let's look at the graph here. For example 5, when I look at the graph, what this is saying is f of 4 equals blank. This means that the input is 4, what is the output? Or x equals 4, what does y equal? In other words, if you write it as an ordered pair, it's 4 comma something. That's what we're looking for. So on this graph, I go to where x is 4, 1, 2, 3, 4, and I want to figure out what is y. So if I go to the graph, this point right here is 4 comma negative 3, which means the input is 4, and the input of 4 has an output of -3. There we go. So f of 4 equals -3. Go ahead and try f of -2 from the graph on your own right now. Now that you've tried this on your own, let's talk through this. This means when x is -2, what does y equal? Okay. Well, when I go to the graph, x is -2 right here. This is the point -2, 0. So when x is -2, so here's my x is -2. What is the output? What is y? Well, that is 0. And there we go. Now I could give you something else. I could tell you f of x is 1. What is x? Well, if f of x equals 1, that's just another way of saying y equals 1. In other words, you have something, 1, and I want to know what the x coordinate is. So now I'm giving you the output, and I want you to find the input, the x coordinate. So if I go to the graph, I'm given y this time. I'm given y is 1. I go over to the graph. This will be the point -4, 1, which means that I'm given the output of 1. I can now find that the input is -4. So if f of x is 1, then x will equal -4. Go ahead and try this next part on your own right now. Now that you've tried it on your own, let's think through this together. This is telling you y is -2, so I go to where y is -2, and that would be this point right here. I go down to go over to the graph. I get +2, -2. In other words, I was given that y equals -2, or I need something, -2. I want to find what is the input when the output is -2. So the input is what I'm looking for here, and the input happens to be 2. So we can use function notation with a graph. Over here, for example 6, now we're looking at a table. Well, if we think of a table, if the thought process is the same, we just find the information differently. So f of -7, again, that's telling you that the input, or x, is -7, meaning you have -7, something. So then I look to the table, I'm trying to find what the output is. So I go to where x is -7, and I find this point right here. I know when x is -7, the output, f of x, is -9. So f of -7 equals -9. In other words, we'll have that point there. Let's talk through this one, and then I'll have you do both of those on your own. It says when f of x equals -9, x is blank. That gives me the output that's saying y is -9, or it's something, -9, and I want to know what the input is. So I go up here, well, that happens to be the exact same point. X is -7. Try these last two on your own, and then watch the video for an explanation. All right, looking here, it says f of -11. That means x equals -11. What does y equal? In other words, it's -11, something. So I go to the table where x is -11. I don't see it. So the only way to figure out what this is if I extend this table and have a pattern. I know that I'm adding 1 each time here. Here, I'm also adding 1. So if I wanted to go to the right more and fill in the table, I would add 1 again, -4, -6, and so on. But I want to get to where x is -11, so I got to work backwards. So I'll subtract 1 each time. Now I find where x is -11. That means that the output is -13, so f of -11 equals -13. This one's telling me that the output is -8, meaning I have something, -8, and I want to know what the input is. I want to know what the x is. So I go to where f of x, so the output is -8, right here, and I know that the input would be -6 in order to get the output of -8. And that is the introduction to function notation.